Hello guys, we are from group 7. Take a look at what we made. This is mosquito genocider. uh, so why we decided to make this? This is because we are living in tropical areas where we face a lot of tropical diseases such as dengue fever, yellow fever, malaria, and other illnesses that's transmitted by mosquitoes. And we need to tackle this problem, but we face several obstacles. That is the inevitable water puddles due to the high intensity of rainfall and the social structure that more focusing in triggers rather than the preventative action. So our goal is to make device that could prevent early mosquito larvae, okay, and make better public health and saving on health expenses. So yeah, we make this mosquito genocider. Okay, so about the mechanism. So take this as the shower walls, and this is the connecting.
Like the connector of our devices.
Yeah.
We have a rope, so it will, when it is immersed, it will not go too far, so it will stay there.
Because this is basically we're gonna put it in water. This is waterproof and water resistant. So okay, when we reach certain level, okay, I'm gonna show the inside.
Yep.
Take a look at this. So basically there is sensor for humidity and temperature and the motion sensor. When it reaches certain environment for larva to live, it's gonna release some toxin. So there is a wire, and this is the servo, and it's gonna push. The servo gonna push the toxin, so it's gonna basically gonna open like this, and this. Okay, sorry, and this, the toxin will be released.
Okay.
And when the toxin is released, it's basically gonna give notification to our handphone, so we know that it's been released. So we need to refill it, and because it's gonna be hard for us to make this automatically close to leave, so we as a human should refill the toxin and then close to leave.
Yes. So basically we're going to, like a semi-automatic system here to release the toxin, and we'll be utilizing gelatin to cover up the toxin so it will dissolve in the water. And when there's like no movement that we censor by utilizing our motion sensor, it will release the toxin and it will dissolve, it will exterminate all the larvae that live there. But even if so, there is no larvae there, I think it is still okay because we're gonna like clean the water and it will stay there, and it will be a preventive action for larvae to not grow there. And yeah, I think that's all for the mechanism, and we'll be explaining more about the certain condition which our device will be working on.
So this device has three sensors which are humidity, temperature, and motion sensor. And the data that collected from the sensors will be shown in this LED OLED. And as we know that mosquito larvae has a certain condition to live, so the suitable environment such as from 18 until 38 Celsius degree for temperature, and more than 70 rate for the humidity, and the mosquito larvae is live in still water. So when this environment is suitable enough to larva to grow, this land will light up, and it's apa ya, when it will send notification to smartphone, but we can't do it yet. And then when at the same time, this servo will open the gate.
So does it work?
It does.
Oh, show us.
Sorry guys, yeah. Technical issue.
Technical issues.
Yeah.
Wait.
Yeah, like this, and then it will thrown up like this. That's all from us.
Yeah. Our goal is basically killing every singularity that is inside of our server. And yeah, I think that is all from me. Oh wait. So we'll be utilizing a 3D printing model to build our devices so that it will be very water resistant and it will be still safe to protect our what is this, sensors. But yeah, it is mushy and we're going to work on it. So yeah, I think that's all from us. Thank you so much.
Thank you so much.
Thank you.
Okay, so I think in terms of keluar nggak suaranya? Oke. You should control your threshold. That means. Anyway, back to the feedback. Back to the feedback. I think overall, I guess like there were some design problems, and you guys only managed to get the servo in the very last minute, right?
Yeah.
So that's why like I could understand that there was like sort of like a design flaw in the contraption, but that's okay. Like I think the idea is pretty good enough at that moment. I'm actually quite interested because I know like you guys are working for this project until like probably June. So I think it will be really cool to see how this will develop by the end of June. And I'm quite interested with like, oh, we want to actually wrap the toxin in like gelatin. I think that's pretty cool. And then I guess like figuring out how to work with waterproof materials because 3D print filaments are not really waterproof per se. So I think overall like this is a good start. You'll just have to refine the design and the idea further so that it works well when you put it under the water. And I guess like because we have limitations of sensors as well. We're hoping that by the time like April comes in, you guys will have more sensors. So yeah, I think for now like this is a good start if you're sticking with this project. You just have to refine the idea so that it's more a well thought out process, I would say.
More comment about the product itself. So because it's a little bit different from what I imagine or what I kind of like see from yesterday concept.
Yeah.
So this is actually more like an ROV. Do you guys know about ROV? Basically like a mini submarine that you can control. So I was like looking at that like that's more like an ROV. So definitely like I kind of have a question like how this thing actually move? Is it just dangling in the water, or does it actually have some kind of propeller to move around a little bit? If you do, actually maybe you can make it like imagine like the Roomba, the vacuum cleaner that can go around by itself. Imagine that application for that. So it actually can go around, release oxygen, and if it's empty, it can actually go back to the station and refill itself. Maybe I don't know.
That's fun.
That's maybe it's a direction that you guys can go to. But yeah, I think that's overall it's a nice presentation.
Okay, thank you so much.
So, who's next?
Next.
Okay, let's go.